just sort of bring this all together now. We're going to say if this is sort of the NC1 term, the NC2 term, the NC3 term, I suppose we could add on the N0 term as well, couldn't we? The N0 term, which would be a 1. Thinking about the expansions from before, I'm going to get sort of something like this, okay? Which brings us to the formula that we actually need to use, which is here underneath, okay? So I haven't gone through the full process really of showing where this comes from, but I'm just sort of showing you some of the intuition. So the first part of an expansion, generally we can say, is going to be 1. Then the next part, okay, so think about if we expanded this bracket here, 1 plus x. Of course, I'm going to have a 1 term from a 1 multiplied by another 1, but there's going to be some kind of x term, isn't there? There are going to be x's multiplied by 1's. So n is the coefficient that I've got here, okay? And similarly, if you look for the next part, n times n minus 1 over 2 factorial, that's the coefficient for this next part, okay? And so on, and so on, and so on. So what I'm showing you really here, without trying to go into too much detail, is showing you with a number example that we've manipulated to algebra, trying to show you where this formula sort of comes from, where the intuition is. And interestingly, it doesn't really seem to have an end to it compared to what we had before. It doesn't seem to be an end to it. And we'll talk about why that is a little bit later. Okay, but that's sort of shown by this fact here that's implying, you know, it keeps going and it keeps going all the way up to here. Okay, so how can we actually use this? Well, we can sort of operationalize this now to find some expansions for some more complicated expressions. So I'm going to use this case here. So comparing how it's written and comparing the form here, this is the same as what when 1 plus x is in the denominator? It's the same as 1 plus x to the minus 1, okay? And the fact here that we're talking about a negative power, that's what sort of makes this the year 13 version of the binomial expansion. And all you have to do really is you have to make sure that it matches the right format. So for example, it's really important that the 1 is a 1, and we'll look at this later. Okay, when it's not the case. It's really important the 1 is a 1. The x, although here it's exactly the same, the x is just whatever occupies this position here. So what I'm actually going to do, and it's going to look quite strange at the moment, is I'm going to say that x is equal to x. And then n is equal to minus 1. Anything else we're going to do? The first 4 terms. So there's the first term, the second term, the third, the fourth. So this is very common that you are asked to find out the first 3 or the first 4 terms. We don't generally go any further than that. And what remains to be done? Well, really, you just sort of have to plug the numbers in. So this is going to be equal to 1, again, just from the formula, plus nx. So I suppose I'm just going to sort of substitute for now. So I'm going to put nx plus n times n minus 1. Well, n is minus 1. Okay, minus 1 is minus 2. So you've got this sort of pattern that you'll often see developing, in which you, in the numerator, you have sort of minus 1, minus 2, minus 3, or something like that. Okay, over 2 factorial, which is just 2 times 1. It's actually just 2, isn't it? I tell you what, I'm actually going to put this in brackets like this, and you'll see why in the harder examples. So there's my first term, my second term, my third term. Okay, and hopefully you're happy with the idea that my next term is going to be like this. Okay, so this is how you actually do the expansion like this. You use this expansion each time, you write it out, you substitute in your n's and then hence your n minus 1s and so on. You're careful with the factorials, and the x, you put the x in a bracket, okay? Because sometimes this x will not be an x. Sometimes the x will be like 2x. So everywhere you see an x here, you would have to put in 2x. Or sometimes it would be minus 2x. So you'd put minus 2x in all these brackets. If you learn this way of doing it, by putting it in the brackets, you won't make mistakes, which loads of people do. After that, we need to simplify, don't we? So 1 plus